Hi guys, let's learn about how to discretize the system. How to discretize the system. Discretize the system means linear system. Suppose you have a non-linear system, and you linearize that one. So from there, now you might have continuous time system of equation, right? But you want to convert that one to discrete time system, and linear and study this one. So how could you do that? Like, to do that one, like, you simply have to use the Euler approximation method or infinitum or or Newton's method or something like that. Okay, so first thing that you should do is write the system equation. For example, you have a system equation x equal to ax plus bu and y equal to cx plus du. Now ax plus bu is continuous time system. In order to discretize that one, you might need x dot equal to xk plus 1 minus xk by t, where t is a sampling period, like at what time interval you are taking a sample or something, right? Sampling period, and xk plus 1, xk is like state, like from this state and the previous state, or the next step and the previous state. Okay, like this one is the future state and this one is the current state. So if you do that one, I'm sorry bro, if you do this one, you'll get x dot equal to axk plus buk. Okay, and this one is dependent on the current state and the current input, and we have a and b as the system dynamics and system input that we are giving, like this input and system dynamics. From here we get equal to, like you can like discretize a and b using let me say, using the methods like Euler approximation method, or you can discretize using Newton's method. Good. So what you do in that one, in Euler and Newton's approximation method, is that yes. Now, in order to like discretize the system using Euler's approximation method and Newton's method, I'm not going into the Euler's approximation method. I'm simply using Newton's method. So you guys should also do that one. Okay. If you want to do using Euler approximation method, I might make another videos. But right now we will do that using Newton's method. Okay. How do you do using Newton's method? Is like simply you will take A and your identity matrix plus AT, and this one will give you the Euler approximation method. Yeah, like Newton's method. And for B, you'll do the BT plus other higher terms, but we are ignoring that one. In this one also higher order terms, but we ignore that one. So in that way, we will like discretize A and we also discretize B. So what we do is like we put this one into this, and you will get your intended equations in discrete time system. So x dot will become I plus AT xk plus BT UK, right? So this is now our discretized equation. Let me give you one example. For example, suppose we have x dot equal to 0, 1, 0, 0, x plus 0, 1, u, which is equal to ax plus bu, right? Now, if we want to discretize this one, what our method is a equal to I plus at, right? We are discretizing using time. So what you do is we have a, this one, and is identity minus 1001 plus e, which is equal to like 0100, and t, we are multiplying with t, so we eventually will get 1t01, right? And we get b is equal to bt, so which will be equal to 0 and the t. Good. Like if you use the higher order term in b, then you'll get like somehow different value, right? Like sometimes you can also use, like I have seen like multiple times, sometimes you can also use bt plus, if we want to include the higher order term, 1 by 2 factorial a b t square, and you'll do that. If you do that one, you'll get t square by 2 and t. Good. So once you discretize the system, you can put that things back into your system and simulate the path. And using this AT and BT, which means like this one is discretized and dependent upon time dependent. This is also time dependent. You can use into the discrete system, time system equation, and simulate the behavior. Okay, now in order to simulate, like for quadrotor, you can simulate I think you can simulate, I think not I have done. So you can simulate path planning, you can simulate trajectory flowing, and you can simulate other behaviors, other things too, like any kind of thing of that system. So this is how you do that, and maybe next time I will do some more comprehensive and other methods. For now, it is all that I have to say, and please subscribe, please. It is my request. I'm trying to uh, make like useful videos and quality videos. If you subscribe, I definitely am going to make more and more quality videos. Thank you for watching this video. Thank you. See you again.